Well, hi there. We are back and ready to dive into section 3.4, where we are going to learn about the derivatives of exponential functions today. We'll save logarithmic functions for another day. I know you can't wait. So we're going to talk about how to take the derivative of not only e to the u, but of any a to the u function. So it doesn't have to be e as a base, but could be any value of an exponential as a base. This is a powerful tool in derivatives, which is going to allow us to do a lot of things with derivatives. So here is a review excuse me, of the power rule. All right, so we learned that if you have x to the n, that n gets moved, down in front, and then your power gets decreased. So this is the power rule. You multiply by n and subtract 1 from the exponent. So this works for any numerical power. Okay, so it can be 0.85. So 0.85 would get moved to the front. 3x minus 1 would remain inside. The power would decrease by 1, which is negative 0.15. And we're required now to use the chain rule, which would multiply this by 3. It works on irrational numbers, like pi. So y prime, remember that this means the sign of the quantity 2x to the pi power. And so pi would move in the front. We'd have the sign of the quantity 2x. We would decrease this by 1. So it's not going to be a rational number. It'll be an irrational number, and you just leave it as decreased by 1. The chain rule requires us to multiply by the cosine of the quantity 2x, and the chain rule again requires us to multiply by 2. So probably eventually you would end up getting rid of the 2 at the end, and probably having the 2 out in the front. So it's 2 pi, and then the quantity sign of 2x to the power pi minus 1 times the cosine of 2x. So that is a review of the power rule. The exponential rule now has the variable in the power. Okay, so the power rule applies to a numerical power. The exponential rule applies to a variable power. So the variable is in the power position. And so the rule is a to the u times the natural log of whatever the value of a is, times essentially the chain rule of the derivative of whatever the power is. So if we apply this rule, we'll come up with the derivative of e. So there are 3 parts to this. Part number 1 is the function itself. So we literally copy the function itself. Part number 2 is the natural log of the constant that you're working with. And so we would have the natural log of e. Part number 3 is the chain rule, which would be the derivative of whatever the variable was with respect to x. Now the natural log of e, we all know, has a value of 1. So we could simplify this as e to the u times du over dx. But it's only in the cases of e that natural log would simplify. Other natural logs are just going to stay at the natural log of the constant. So let's try it out. Find the derivative of y with a constant base of 3 and a variable power of x to the second. So dy dx, okay, the first part number 1, is 3x to the second. That doesn't remain, it's part of its own derivative. And then multiplied by the natural log of the constant base of 3, and then multiplied by the derivative of the variable power, which would be 2x. So it's a pretty straightforward derivative. You will typically see it written in this way. 2x first and ln 3 separated from the 3 to the x squared. So that's typically how you'll see that written. Here's another example. Okay, our y prime, because this is an exponential base with a variable power, constant base, variable power, then we'll follow the three-step process. So 5 to the cotangent of 3x is in its own derivative times the natural log of 5 times the derivative of cotangent, which is negative cosecant squared. And then we're required to use the derivative, the chain rule, so that would be 3. So you will most likely see this written this way. The negative 3 ln 5 followed by the cosecant squared of 3x, and then followed by either a multiplication or maybe another parentheses or something of 5 cotangent 3x. Probably another parentheses maybe. All right, here's an exponential where the base is e. So dy dx, e to the x cubed is part of its own derivative, times the natural log of e, times 3x squared as the chain rule. And so we would typically write that as 3x squared in the front, and then e to the x cubed, where the natural log of e simplifies to 1. We can find a tangent line using these same derivative rules. So first we would need our point. The point will be pi, and then e to the sine of 2 pi. What is the sine of 2 pi? Well, it's 0, so that would be e to the 0. And then e to the 0 is 1. So the point we're working with is the point pi 1. The slope would be the value of y prime. So the value would be, the first step is e to the sine of 2x is part of its own derivative, times the natural log of e, times the cosine of 2x, times the chain rule of 2. We know that this is going to be 1, but we want to know what will happen when we plug pi into all the rest of these. So e to the sine of 2 pi times the cosine of 2 pi times the value of 2. So I think I'm going to put my value of 2 out in the front, right out here. So that'll give me 2 times e to the 0, which we know is going to be 1, and the cosine of 2 pi, which is also 1. So we have a slope value of 2. So our tangent line would use the point and the slope. So y minus 1, slope value of 2, x minus pi. So let's review the rules that we would have for these different derivatives. Find the derivative of y to the third. We have a constant, and we have another constant. So we will be using the constant rule. And the constant rule says that the derivative, y prime, is 0, because the derivative of any constant is 0. For the second one, we have a variable, followed by a constant, which is going to need a different rule, and it will need the product rule. excuse me, misspoke. The power rule, so sorry. And so the derivative of this, using the power rule, would be bring the 3 to the front and decrease the numerical power by 1. And in our last example, we have a constant first, followed by the variable as part of the power. And so this is going to need the exponential rule. And so the exponential rule would say that y prime is part of its own derivative times the natural log of 4 times the chain rule of 1. So probably best written as 2 natural log 2 times 4 to the x. So you might be thinking about the last combination that we haven't covered yet. Okay, and that would be the combination. What do you do if y is equal and it has a variable as its base and a variable as its power? So we've done, all of these have a constant at least somewhere. But what do you do if there's no constant at all? Well, that's going to need logarithms, and so that's setting up what we're going to do later this week, needing a logarithm to have a new rule to take the derivative in that situation. So practice the exponential rule, but watch out. Some of the questions have some of the constant rules or power rules in there too, just to keep you on your toes so that you're not so zeroed in on the exponential rule you forget about the other ones. All right, we'll talk about logarithms on Thursday. We'll see you then.